Started. Okay, it's recording, right? Yes. So we are going to continue from networking where we stopped in the last class. So I believe that you have
Yes, sir.
this notes. Okay. So let me scroll down. Where did we stop? Trial.
Yes, sir.
Trial. Where did we stop?
I think you were talking about the difference between TCP and UDP. Let me
Okay.
check the
Like
note.
okay.
Um, okay, we
Um,
talked about FTP, TCP, and UDP.
I didn't
And you
know.
told us to,
Did I give you any assignment?
yes, told us to check up on quick UDP
Okay.
and
Okay.
like its advantages and disadvantages.
Okay. So we're able to
You
finish
also
that.
told, yes, quick UDP is like a cross between TCP and UDP, but like it's built on UDP. It's just like is while TCP is secure and UDP is fast, quick UDP is both secure and fast. So there are some
Okay.
features that's um beneficial, like independent stream multiplexing. I think that means it can send like more than one stream, and then even if one of the streams fail, the other ones can still go ahead.
Okay.
And then it's
Okay.
encrypted and some other
Okay.
benefits.
Okay. That is nice. That is okay. Okay. So we're going to
Although
continue. You said?
I just want to apologize, I was not able to do the whole assignment. I think you also told
Okay.
us to visit Bandit over the wire. I was not able to that one. Sure.
Okay. Okay. So okay, we're still going to work on that. But you guys need to do that too, so that your Linux will be strong. Because if you just passively learn Linux, you will never be able to do things on Linux. So by doing those capture the flags, you'll be able to understand, and it will just give you the basic understanding with Linux and to help you practice it. That's the thing.
All right, sir.
So I'm just okay. So where we're going to continue from, we're going to continue from here. This TCP. So I think I've explained this part, most of it in class, but I'm going to say it again. So in a TCP handshake, let me show you an image here on a typical image. So let me just TCP handshake. So how it works is that we have this kind of connection called a client server network connection. And how I'm trying to get a big image of this. Okay. Okay. So how it works here is that we have a client and we have a server. So the client sends a synchronization message. Basically, this synchronization message is um what's up? I want to talk to you. The server responds with a synchronization plus acknowledgement. So it acknowledges that it has received the synchronization message and is sending its own synchronization message along with the acknowledgement. So it's saying, yeah, I just received your message and I also want to talk to you. Then the client says, acknowledges that he has gotten this last message. So he says, okay, I've gotten that you want to talk to me and you have your acknowledgement. So I'm going to acknowledge. Sorry, he's sending back the acknowledgement that you have synchronized and you want to talk to him. So he sends back an acknowledgement, and now both client and server they are connected. So they can now start sharing messages between each other, or um, they can now start communicating with each other. Now, can you hear me?
Yes, sir. Yes, sir.
Okay. So without this TCP, This is what allows TCP to work because TCP is connection oriented, meaning that it needs to complete this connection before you can communicate, right? So I think I give you an assignment before. There is an attack which an attacker will just send, not really an attack, but what an attacker will try to do is they will send a sync and a sync arc. Sorry, they'll send a sync and the server will send a sync arc. They can use this to get um the open ports. This is what they use for port scanning. So basically, port scanning is like checking which ports are open or filtered or closed. So when they send a sync, depending on how the server responds, they will know whether the port is open, closed, or filtered. So I think I should give you that as an assignment. So what you should do is when a client sends a sync, what kind of response would the server respond if the port is open? If it sends if the port is closed, what kind of response would you respond to? Would you what kind of response would be gotten? And if the port is filtered, what kind of response would be gotten? Basically, filtered is like there's a firewall blocking it. So if a client sends a sync, what kind of response? When it's closed, open, or filtered, what kind of response would the server respond with? That's your first assignment. I would say,
Okay.
okay. So you use that in port scanning. So that's what they use to. That's like the metrics they use to know whether know which port is closed, opened, or filtered. So I don't know if you have worked with a tool called Nmap.
Yes, I had our IT
Okay,
tutor made us do that extensively.
okay. So basically, that's how. And Nmap is not only a port scanning tool, but it does port scan. So um, it uses this kind of idea to do it. So maybe I don't know if we go into Python or maybe script maybe like a simple port scanner. So actually illustrate this so that we understand it better. Yeah. So let me get back to the notes. So look at it here. The client to server. Client says, I want to connect. Here is my initial synchronization. Then the server sends back to the client, okay, I accept. Here is my synchronization number. Acknowledge yours. And the server says, client to server, got it. Connection established. Let's send data. So you can read all this part. So basically, why TCP handshake exists is so that both client and server can be connected and message can then be transferred so that in case there is any packet that is lost, it can resend that packet again. Okay. So basically UDP is connectionless. It does not do the whole TCP handshake stuff. It just skips over it and starts sending data. So it doesn't check whether the server is connected. It doesn't care about that whole thing. Its work is just to get data over to the other side. Its work is just to send as fast as possible. That is its work. So UDP connectionless, just send. Best effort, packet may drop or reorder. So it's faster because it doesn't have to waste time doing the connection. TCP is slower and the header size. Okay, I think I should also give it. Wait, did I drop the header here? I think it. You guys do that as an assignment also. How many assignments have I given you? Are you with me?
Like for this lesson or
No, like for this one.
for for this topic.
Yeah, I can hear you.
You have so far just said what kind of response would the server respond with for
Okay,
open, close, and block.
okay. So next assignment I want to give you is sketch the TCP header. Basically, sketch it and then after sketching it, you're going to map it. Okay, I don't think I've done this part with you, but just the assignment, sketch the TCP header. And by the next class, we're going to map it with something on Wireshark. We're going to see how it looks on Wireshark. So just sketch it.
Um,
Mm,
what do you mean like sketch? Like writing the details that will be on a TCP packet.
Yeah, like
A TCP.
let me show you. TCP header. You'll see things like synchronization number. So it's just a diagram. So something like this.
Okay.
Source port, destination port. So after you sketch it, there's a way it's structured. So when you see a TCP header, there's a way, just like a bunch of hexadecimal numbers. There's a way it's structured. From the structure, you know the source port, the destination port, the sequence number, acknowledgement number, everything from the header. So the header is just a bunch of hexadecimal numbers that we can pick out these things from. Do you understand? Triumph.
Sorry, like the connection was breaking a little bit over on my side.
Okay. Okay. So I just sketch this. Then we are going to. I'm going to explain how we're going to map it to we're going to see how it looks in real life. So
All right, all right.
okay. So
That's
next,
TCP or UDP, the header.
both TCP and UDP.
Okay, both.
Yeah, they are different. The headers that look different. You see, I think TCP. There are some things on TCP you'll not find on UDP.
Okay, okay, okay.
So look at the use case. So the use case, a lot of protocols that we use run on TCP. For example, like HTTPS, we are trying to make sure that whatever we're sending from our servers and is being rendered on our screen is there. So we're prioritizing reliability when we're dealing with web applications, right? For emails, if I'm trying to send an email from me, basically I'm trying to send an email to you right now. I want to make sure that the email gets to you, right? So definitely that is my primary concern. I don't care how fast it gets to you, whether it takes 30 minutes to get to you, just as long as it gets to you. File transfer, basically the same thing. Remote access with SSH, same thing here. But using TCP. But things that use the UDP, things like gaming, we're concerned with speed here. Things like streaming, we're also concerned with speed. So error recovery, with TCP, yes, we can recover the data back. I don't know if you guys did. Okay, yes, you guys definitely did it. This course, what is it again? I think I've forgotten it. But on the OSI layer, where they talked about, I've forgotten the course.
Okay.
Oh, forgotten. I've forgotten. Well, basically, let me just
System.
I said,
I think is system communication and network or
yes,
something.
something like that. uh So, um, so for error, so TCP basically handles not it can transmit data. So let's say some data was lost, it will find the range of packets that were lost and can retransmit it. But UDP cannot handle that. It does not know because there's no connection. It does not know what data was lost or what data did not go at all. So it can't do that basically. So the next thing we want to do is go straight into the lab. Let me check something. Okay, I thought I had something. One sec. Where is my notes? So this lab says TCP handshake capture. So basically, we want to capture a TCP handshake. Now, the tool we're going to be using is Wireshark. So basically, Wireshark is a traffic. It captures traffic. It sniffs traffic. That means basically it's just finding out the whole traffic running on the network. So you can run Wireshark. Do I have it on my Windows here? I've not installed it. So just turn on your Kali. Open your Kali. My Kali is having a little problem, so it's not going to give me full screen, but I think we should still be able to work with it. So it's just booting.
Yes, sir.
Um, So it's just this small window I'm going to use for the Kali. Kali is misbehaving today. Okay. Can you see this? Okay, good.
Yes, sir.
So I'm going to run Wireshark. So you can just set it up here. Once it opens. Now, have you have you turned on your own Kali?
Yes, the screen has come on, but it's still loading.
Okay.
Okay. Okay. Wireshark.
Have you is it on?
Yes.
Okay. So the first thing you're going to notice is the capture using this filter, blah blah blah, on interfaces. So this is just this drop down menu or whatever you call it, or this stuff like this. They're just the interfaces that you have. Remember, we can check the interfaces on our network card by using I, ifconfig or IPA.
Okay, these are the same things there.
Yeah, these are the same thing, but that one contains more. So these are the ones on our interface that we have currently. So we have,
Okay.
for me, I have internet zero, internet one. Yours would just be two if you have no, just maybe two. For me, I added more adapters, so maybe that's why I have more. So yours could be two, it could be more depending if you have added another adapter. I mean,
Okay.
so
Yes, sir.
okay, so if you notice, so I think it's ETH1 that I'll be using. I think this is the one that is that this. Okay, I think it's this one. ETH1 or ETH0 that is connected to the internet. Let me check. So if you look at this, I looking at this. This stuff tells you the network activity. So let's look at ETH0 has a little network activity, ETH1 little, ETH2 little, but I feel like it's ETH0 um that is connected to the internet. Let me try something first. Let me just try and search to be sure that it's not connected. I'm just pressing google.com again. That is working. So which one? This one didn't pull anything out. So look at this ETH1. Immediately I searched something, it started moving. So let's see this guy. Are you seeing this?
Yes. Yes, sir.
Okay. So it's capturing everything that is going on in my network now. Now, when I searched where is this? Google.com, it's pulling out every single thing request that is happening in my network that is going to google.com. So let's look at this and actually analyze it and see what's actually happening. It's plenty. Plenty. So if you look at Z quick here, TCP, so UDP is not here. Yeah, sure, we're not doing anything that require UDP. So the main thing we want to do now, we want to see how this TCP handshake actually looks in Wireshark. That is the raw request. So I think there's a command for it. That is the filter. We can filter for TCP by doing TCP. Come on, Wireshark. Let me. I think I have it in that note. How is it? Where's my note? TCP dot flag. Ah, this is not allowed to copy. Can you hear me?
Yes, sir.
Okay. So let me see something. Sync. Okay. So basically, what this TCP, this filter does, I think, uh, don't give you another assignment again. Sure, I'll give you it's for the best. So, what this does is that it filters for the synchronization. I think this one stands for TCP sync attacks. All these commands for Wireshark, that's long ago. But you can practice it. Have you tried me before? Mm. Try Triumph. Triumph. Are you there with me? Triumph. Triumph. Maybe it is internet. Okay, you can't hear me. Okay. So have you used me before?
TryHackMe.
Yeah.
Or you are
Hmm? Triumph, are you with me? Triumph, are you with me? Ah, why are all these rooms premium now? Can you hear me? Triumph.
yes.
Okay.
Hello.
Yeah, I can hear you. I can hear you. I say, can you hear me?
All right. Yes, sir.
Okay. There's no free one. So just check online how to try Wireshark filtering commands or capture. Just learn how to capture stuff with Wireshark. So for now, I'm just going to show you. So the TCP flags or SN equals one. What it does is it captures um synchronization, basically any single TCP handshake. So when I press enter, what it's trying to do, I listening, I me, triumph, triumph.
Hello. I think
Can you hear me?
I can hear you now, but I think the network cut you off at that point. What did you say last?
Okay, okay,
What did you
okay,
say last?
okay, okay. I said, can you hear me?
Yes, sir. Yes, sir.
Okay. So if you look at this, trying to see something. Okay, if you look at this, you would let me clear this and
Right.
start it again so
That's
that Okay. So it's capturing. Let me just say something like google.com presenter come back to Washak. So now I will search for headers, like CCP header. Now if you look at this, first of all, the first thing that is being sent, are you with me? Is the synchronization. This one. Triumph, triumph, triumph. Ah, on. Are you with
Okay.
me? Okay. So I say the first thing that I sent is your synchronization. So
Okay.
so let's look at this. The source is from my IP address. It's my IP address 10.0.2.4. It sends a synchronization to this website, right? To this IP, sorry, using the protocol TCP. See the synchronization here. Are you with me?
Yes, sir.
The IP sends back the response to this my IP address is with a sync ACK. Are you with me?
Okay. Okay.
So I'm looking for the what called acknowledgement. So we have a sync ACK. I'm not even supposed to follow. Sync, 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 sync ACK. Let me check something. So wait, I'm coming. I think let me try something. This is a vulnerable website where you can just check things. Okay. So I will me.
Yes, sir.
So I'm just going to place it somewhere around here, and I'm going to let me clear this first. Pause this from running. I'm going to try logging in. Sorry, pause that from running again. Start it again. So I'm going to log in. What is going on? Not reflecting. TP. Sorry, where is it safe? Okay, it's not reflecting. Yeah. Are we on the wrong interface? Okay, what are filtering for this? Okay, so are you with me?
Yes, sir.
Okay, I'm just going to quickly search it. I think that command is wrong. Um, CSP, CSP, handshake feels the Bioshock. Okay, actually, this is okay. This will do it. Draw packets. Mm-hmm. So this first one only shows sync and sync arc. That's why we could not find the arc. So let's try this one. This one will show all of them. So we can just check that. Where's my this? So now that we have, we can search, we can filter for it. Do you understand what I'm doing?
You're like looking for a certain head protocols in the header.
I'm looking for the what do you call it? The handshake itself. So I could use the handshake to see whether an attacker is sending is trying to probe our network. So basically an attacker can send only the sync. It will not send the complete request like sync. Then the
Yeah,
rest the website will respond with sync and arc. Then finally an
yeah.
acknowledgement. The attacker will only send the sync, and the reason why he's sending the sync is just to see how the web or the server will respond.
Okay, yeah, that's true.
So if we see an attacker that is just trying to probe this network and is just sending a sync, we know that there's an attacker with so IP address trying to probe our network. So we can kick that guy off our network. If or do you understand?
Yes, sir. Yes.
I think I even need to go and study this Wireshark like more in depth. So just need to make out time to go into this looting of some. I don't know, my copy is not working here. So I have to go through the long routes. Okay, good. Um no, I can't see the sync again. Right there. What is going on? Not showing me. You're not showing me this thing now. No, it's on. I'm not seeing long. I'm not finding the sync. Blah, 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 blah. Okay, I've gotten it. So we could use this. I don't know why there's a way I used to do it to show all three of them. But basically, what is happening here is that I'm trying to see. Are you with me? Are you with me? Triumph, 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 triumph. Can you hear me? Oh, So let me just start this guy up in the group chat. So what I'm saying is that so the first thing we have to do is this is the sync. So for the sync, we can just do TCP. Like this one. This one will show us the sync and the sync hack. So when we press enter, we notice that there's a sync, there's a synchronization from our IP address. Remember, this was our IP address. Let me show that to you. So we could just do IP config, and I think this is the IP address for ETH1, which is what is Linux. This interface is what is Linux connected to the internet. So we could do that. Notice that this source is communicating with this destination, that is this IP address, and is a synchronization. Then it sends that same synchronization again. This is the port. It's sending from this unknown port, I don't know the port, to HTTPS. So then there's a response from this port, this one, back to 10.0.2.4, and it's from 443 HTTPS to this port, and this is sync and the sync hack. So then this is from this first request back to my IP address 443 to this port, and it's a sync hack. So we can now check the acknowledgement with this other one. Sorry, no, that's not this guy. Who is that first guy? This one. Now, if I go up, you see the acknowledgements. So I think see the acknowledgement for that one sends back from this port 49048 to 443. This is the acknowledgement request back to this destination. So let me check whether this guy is up. Triumph, Triumph. This is not. Okay, so let's just continue regardless. So the next I want to show is port scanning using Nmap. So Nmap has a lot of things. So there are a lot of ways to scan using Nmap. We can't go fully into that. That would be like a whole class on the whole of Nmap. I'm just going to show you how to pull version. I'm going to show you how to do stealth scan and the basic Nmap scan. So I think there's a GUI version that is ZenMap. I think Kali has it. Let me just stop. So I think we get that. Let me check. ZenMap is the GUI version, so you could just pull that up quickly. So if you notice, you could just use this to do your scan. We have the intent scan, ping scan, quick trace route scan, all of that. So I'm just going to pick a regular ping scan, and the command is nmap-n. Let's see, the IP address is my IP address 10.0.0. What am I using? The 0.2.4, this one, the 0.2.4. I'm going to just scan my IP address and see. I think it's a ping scanner right now. So it's just see whether the IP address is on, which it should be on. It's active. So ping scan, scanning it. Should not take time, except I put the wrong IP address. The 2.4. So on IPS, okay, it has scanned it. Host is up. Okay, sorry, it was a pink scan, so it's not pulling out any stuff, not pulling out any open ports or anything. So I could go for an intent scan. So it's doing that. Let's see what it gets. Covered open port. So port 80 is open, port 22 is open, SSH, HTTP. So we could just go to host details. So we see two ports are open. Scans. Okay. Yeah. So it also put out the version. There is something, the version that is on the banner, that is, this one is using the open SSH 10 dot blah blah blah, and this HTTP is running on an Nginx server. So basically, what we can use this to do, there was this vulnerability assessment I was doing, and it pulled out the version, and it was a vulnerable server. So you could add that to the list of vulnerabilities that you have that is there, and the server was exploitable because it not just fall into the version, it also was exploitable. So that is one thing I also add to that. So you can also use the nmap command on our terminal, straight from our terminal. So we have the first type, which is the, I just want to write this out here, um the version puller. I'll just call it that, version puller. It's just, oh, so how this works is that we are going to just pull out the banner. That means the version of the banner basically contains the version. So let me just show you how it works. So we could just simply do nmap dash a small s, and we use d to specify that we want to just get the version. We want to do a port scan and get the version. So I'm going to use 10.0.0.2.4. Please do not carry out any active reconnaissance on a website or a target that you are not giving permission to. That is a disclaimer. Please, like as you see, I'm doing it on my own IP address. So please just try to carry it out on your own IP address, not on something that you don't have access or you don't have permission to do it on. So scanning shouldn't take this long now. Okay, so you see, you put out the version open SSH and Nginx. So you could do that. Then there is a stealth scan. Now, what the stealth scan does is that it just sends a synchronization message. It doesn't send um the full handshake, but it doesn't complete the full handshake. So it breaks up from the full handshake. Let's see. So it just tells us SSH. So this is just to evade old detection methods. So some detection methods usually capture it when it has a full connection. So this is easy fix now. You could just say, I want to capture every single one that either I had a full connection or even just um half connection, basically, maybe just a sync attack, just a sync organization message. So it put out the services run SSH and HTTP. So by service running does not mean that it's vulnerable. Basically, service running just means that service is active. Means that I can do SSH, I can SSH um into any remote system that I have access to. So if I have the keys, or if it's password based, if I have password, I could log into that system. And HTTP, I can connect to HTTP sites. Doesn't still mean that it's vulnerable. It just means that I have a huge attack surface that attackers could get into my PC from, because they could, if I can log into a HTTP website, means they can create one and somehow use phishing to get it to me. And if I can tap on it and I'm in the same network with them, and I enter any of my credentials into that website, they will be able to steal it. So that is one thing you can do with it. So let's get back to the notes. So we have worked with TCP handshake and port scanning using nmap. Okay. I just want to introduce us to this. Okay, let me introduce. Okay, so I'm not going to do much here. I'm just going to run commands. All these are like theory. So basically, what JNS does, JNS translates domains. So domains are basically this human readable text that we have all the time when we search up websites. So let's say I go to google.com. Google.com is a domain. So it's something that we can read, but basically, internet does not understand what google.com means. So it needs to transcribe or resolve this google.com to something it understands. Basically, the internet just understands IP addresses. So it needs to resolve this. So it's going to take this and it's going to take it to something called a domain name server. Now, the domain name server, what it does is that it resolves this, changes this text that we all know into an IP address that I can search up. So an example of a domain name server is Google DNS, that's the Google domain name server, and it's you can easily get it on just I think the IP is 8.8.8.8. So it's Google public DNS server. So when we press enter, it takes us here. So let's say I search facebook.com. Yeah, I already have it here. Now, when we search facebook.com regularly on our browser, what happens is that it takes this facebook.com, takes it to this DNS, checks it up, pulls up the IP address and searches it. And before it searches it, it just takes you around the route. So we'll get to that later. But it searches it. So this what it's going to do, it's going to take it to something like this Google public DNS and it's going to resolve it. So after resolving it, it's going to get this like JSON format stuff. But what it's just trying to pull out here is the data. Now, this data contains the IP address. So the IP address is 57.144.38.1. Now, this is one of Facebook servers. Now, Facebook does not allow us, I've tried this before, but Facebook does not allow us to connect to their servers via the IP address because maybe this server is for something protected or whatever and doesn't let us do that. So to block us, so let us do it. Something went wrong, but Google allows us to do it. Google.com resolve. We have this. So you could search this up. Your data could be different. Your this IP address could be different. This is because we have multiple servers. Google can have like multiple servers. Maybe for redundant. Maybe some are redundant. Maybe as they work as backup. So if one server fails, it directs you to the second server. And also we could have multiple servers just so that in case one server is filled up, another one can. So basically, mostly for redundancy. So you could pull out when you do the DNS lookup, it could give you a different server. So it just means that your routing is getting to a different server that mine didn't get to first. So you got to this one, yours could get to a different one first. So I could just search this up and Google allows us to pull this out. So you can just play around with this. Okay. So another way we can do this instead of going to 8.8.8.8, that is this 8.8.8.8, that is Google's DNS server. I think there's one that is 8.1.4.4. I think that's Cloudflare or something like that. Oh, still Google. There's 1.1.1.1. Okay, I think this is Cloudflare. Yeah, 1.1.1.1 is Cloudflare. So it's another open DNS server. It's public, so you can also try it out. So you could use Google's and you could use Cloudflare's to pull out the IP address from the domain or resolve the IP address from the domain. So next that we are going to touch is how we can do the same thing in our terminal. So on Kali, we can just do ns lookup. NS lookup pulls this thing out for us. So we could do ns lookup google.com and it does that quickly. Now notice we have a different IP address here. It's just another server that it was able to get before this. So he put up another server, and um, basically that's how NS lookup works. Just resolves the domain to the IP address. So another one we can use is dig. So we could just do diggoogle.com. Please, when you're taking this, you can just go back, understand this whole thing, because I'm going fast. I know I'm going fast. So just go back, understand the whole thing, then get it. So let me just make this full screen. So you notice dig gave us the IP address. So we're lucky we got the same IP address as before with dig. So it got to this server again. So that is just how they work. They both do the same work. That is the command dig and the command ns lookup. They both resolve domain name into IP addresses. Hope you understand. Okay. So you can just read on this, drop on this, all this English. It's important too. It's important. So next thing I want to show you, I don't want to finish this whole thing. Say, okay, we can finish it. Not much. Not the whole topic, just this. In DHCP. So how does DHCP work? What is DHCP and why do we need DHCP? So DHCP just stands for Dynamic Host Configuration Protocol. So we have basically two ways of configuring a device or giving a device an IP address or an IP configuration. That is the IP address, the subnet marks, the kini, all of them. We have the static, we have the dynamic. The static, that is for manually entering it. So I could show you. Wait, packet tracer. What is this here? What is going on? So let me just change this. Some balance. Change that. I beg, it's not needed. Why is it not slow? It was unbalanced. Okay, so let's just look at a simple configuration here, a simple topology. Sorry. So assuming I have two PCs, um, a switch, William switch the another one. Do I need this? No, let me take it out. So I have this two PCs, a switch. I'll add a router. Fast forward this there. Draw like this. Does it have the latest? This is random router. It's one. So this is so basically we have a switch, we have a router. So then I'm just trying to what configuration is this? What interface is this with? There is Giganote 3 and Giganote 0. Okay, fast internet 3 and 0. Okay, great. So basically, what happens here is that we have two ways of um configuring this. We can configure this manually by first configuring this router manually. We go to the configure. As long I did this, there's supposed to be a desktop here. Okay, yeah. So you can configure this manually by going here, putting the IP address, putting the subnet marks, all of that, all this you can do that. But we don't want to do it like that. We want a DHCP server to do this for us. So a DHCP server just randomly assigns IP address and IP address configurations are random. So you give it a range and it does it for us. So that's what a DHCP does. It does it automatically. So there's something I need to tell you guys. Okay, we're going to see it. So first of all, let me configure this one. Let me configure this one using let me configure it using static. I'm just going to give you 192.168.1.2 subnet max. Let me make it 255.0.0.0. Basically, it means that this portion can is not changing. This portion can change all the way from 0 to 255 to 254 actually. But let's leave that there. So um after that is I think that's configured, right? So now let me give this one also. I'm going to remove both of them so we can also check it using 192.168.1.3. Basically, I'm supposed to give you the least amount of subnets mark, the least subnet marks, but we can work with this for our router. I'm just doing this manually. This is the manual configuration. Just imagine we have a company with 10,000 computers and we have to do this manually. Just imagine how hard that would be. Um, yeah, so I connected to Ethernet 0, Ethernet 0. So I could just put an IP configuration 192.168.1.1 and the IP address 0. So this is our default gateway. I didn't put that in the last one. I'm just going to copy this. But I don't think we don't need this. We don't actually need a default gateway right now because we're not trying to send this to a different network. So we could leave it at that. So let's just try sending something from this all the way to this. Successful. It works. Right. I think it will. Um, I think we should increase it so that it will look more realistic. Let's try and send to a different network. Let me just put another router. I have an idea. So put another router. Why don't I just copy and paste this one? So I just copied and pasted it. Okay. So let's configure the second side. So I'm going to start with the router. Config this part. What is it connected on? One. So I'm going to turn this one off. It's off basically. We don't need all this. So you can just leave that. But one is what we're looking at 192.168.1 dot let me do 2.1. This is PD 2.1 network. It overlaps. It's 0. This is off. So to the one. So I'm going to give this to that two. And I'm going to give this to that three. So after saving that, I'm just going to um turn this bad guy on. I'll turn it down on. Why is you know? Okay, I didn't turn it down. This one is on. This is 0 0, and this is 0 1. 0 0 0 1. So on. So this one is 0 1. Ah, mistake. Forgot. I don't want to go deep into routing now. So I'm just going to delete one of these routers. Sorry for taking around these routes. I sorted it there. So I'm taking on this route. If you don't get the joke, it means that you're not following this networking class. Hope my joke is not boring. So okay. So I didn't just want to do that whole routing of a thing. So just take our time. So we can just do this. So this is our 2.1 network. Let's put something here. 192.168.2.1. These are 2.0 networks, right? And this is our 192.168.1.0 network. So we have this network, we have this network, and we have a gateway. So we have a gateway. One dot one. Okay. So we have this one. Let me cancel this first. Let me see what we're doing. Let me try and ping it first. I think I'm making a mistake somewhere, but let me just try pinging this. To this. It's not going to work. I've not set up the gateway on this guy. For gateway. 192.168. Oh, I'm just setting up this gateway. 192.168.2.1 is overlapping. Still don't want already available. What else we can do? There's my oh, let me see that this. Wait, let me see something. Let me try something from this guy to this guy and see it in some simulation. So basically what I'm using to filter is for ICMP. ICMP is for ping. So I will delete this ping from this network to this other network. So it's not working at all. That means the IP configuration is wrong. Last minute. What is happening? Yeah, good job. Oh, oh, the goal is just to show the GPU. This one, I think it's just ah. So I'm just going to leave this. The stress is too much. So what I'm going to do is just use JCP and do this thing. One say since I do this one like this. So I'm just going to connect a DHCP server to this thing and do it with a DHCP server. Okay. So connecting a DHCP server, I can just come to end devices server, drop one here. After dropping one here. For reasons like this, stuff I don't that they made it DHCP. Where the person just is stressed like this. So I'm just going to do two. One for this network and another one for this other network. So the first is configure this one and make sure it works. So we come to DHCP, we're going to come to services, we're going to come, sorry, not HTTP, DHCP. This thing is not showing. Let me just make it visible. Okay, so let's try that again. So let's just do it dynamically. Let's just give it everything. So I'm going to leave this name as server pool. I'm going to turn the service on. I'm going to come, I'm going to give it a default gateway. Default that I'm going to give 192.168.1.1. I'm going to give it a DNS. Okay, leave the DNS. We're not working DNS here. So I'm going to give it a start IP address. So the IP address is to start. Remember, DHCP gives it randomly. So it needs to know where it starts and where it ends. So it needs to know the range of IP address it can allocate to these devices. So I'm going to give it this. Dot one from, so you should start giving it from 2 or so the IP address, the subnet max, right? Subnet max will be 255. Let's just use a smaller subnet max, like 255. The 0 number of users, we just need 2, but I'm just going to give it 10. So after this, we'll save it. It has saved. Then, what does that do? Okay. So after saving this, we have this saved. So I could come to this device, go to IP configuration, and instead of doing this, I could just do DHCP. See whether it's going to work. It's taking too long. Basically, if DHCP fails, it will use APIPA. APIPA is like our system giving it an IP address. So you see the IP address be like 169.254 or something. So that is just it using APIPA. Looks something like this. So if I think something is wrong with our DHCP, so it will fail. What is this now? Get out of my site. So is Apipa. Apipa is after DHCP has failed. Oh, wait, though. See, I'm not gonna video. How do you talk to myself since? Okay, I feel. So, okay. So let's check that DHCP server again. Or is it? Uh, Take it back to static. And it's not still working. Let's take it back. Let's see what's going on with our DHCP server. So DHCP is on, service is on, um, full gateway this, start from 1 to 2, 255, 255, number of devices 10. Okay. Um, let me take a look. Okay, let me try something. What is going on? So, I swap. Wait, another server. Let me back on. Let me back on. So it's from 1.1 to this, 1 to this. Okay. Let me try this one. Oh, I've not given the DHCP server an IP address. No wonder. So look at, we need to give the DHCP server an IP address. So I'm going to give it 192.168.1.3. You know, the other ones have been given. So it should work now. So I'm going to stack click, press the IP address. Let's do greedy work. What is going on now? Let's give it a few seconds. Not working. Check what is going on. This IP address standard plus the services. Let's see whether I can reach it first. Okay, can't reach this. Can't ping anything here. Let's try something. In progress. This is simulation. Real time based successful simulation. I send it successfully. So okay. So that means the DHCP server, you can reach it. So it's probably the okay, finally it worked. Worked. So when we just mentioned DHCP requesting IP address, one from one now. It just work now. This is this problem now. Let's try and ping it again. I think the head is come straight after you ping. It's on simulation. Let's put it on real time. So come here. Just DHCP. See, give us IP address, so we can put it on static to get a new one. And go to the put it on static, then take it back to the dynamic. We'll get a new one. So we got a new DHCP request successful. Okay. You still give us the same one, sure, but it's randomly allocating this net. So we have 192.168.1.4 within our range. We have the subnet maps and we have the default gateway. So we could just instead of configuring this thing one by one, we could just use DHCP. So you see the problem that I had doing it manually. DHCP has given this one too. So I could just do the same thing here and DHCP does the same. Yeah, I don't know if you understand. So that is that. So another thing, so that's how DHCP works. So we need to also understand the four messages the DHCP sends. So when DHCP or when the DHCP server wants to connect, the first thing is that the client broadcasts, I need an IP address. So this guy shouts, I need an IP address to the DHCP server. He sends a request to the DHCP server. I think I have a note on this. I think it's called yeah, I forgot the name they call this thing. Maybe it's where it's not. So it sends I need an IP address. Is there a DHCP server? DHCP server responds on the unicast. Now remember what we did I think when we started this class in the classes of IP, we have the class A, class B, class C, class D. Remember the class D is the unicast or the broadcast. So it has it's a subnet box looks something like um there's a range for this. Let me just show you. Class D IP address. Okay, class D or class E. Okay, as unicast. Oh, unicast. Okay, this sorry. Yes. What am I doing? Class D. Class D is from, okay, look at it, 224 to this. Now, since it's from 2, sorry. So, I'm trying to remember which one is unicast. I think it's class E. What multicast? Sorry, what IP address? So, what multicast is that it's only it doesn't have any IP address, doesn't have any host. So what it does is that it acts like the broadcast and sends messages to every single devices in the network. Okay, look at the IP address that is multicast. So any IP address starting with this. So the range is from, okay, this is the class D to this. So it's multicast. All it does is sends IP address to every single host, like the broadcast IP address. Oh, I'm mixing it up. Um, where's the note? Okay, so DHCP's response with the unicast or the broadcast, okay, you can do both. So basically, the broadcast is one responding to every single device in the host. Unicast is just that one that we set up. So I offer this for 24 hours. So it gives you the time limit that is going to offer the random IP address that it has wants to allocate to you. So in this case, it allocates 168 or 1.4, says I offer this for so hours, and it sends it to it. Um, Clients broadcast accept the offer from server X. This DHCP server, the DHCP server we have, it accepts that. Then it sends an acknowledgement. Server confirms this and to expire so time. Here is the subnet mask, gateway, and DNS if you have configured that on the DHCP server. So DHCP server, there's an attack. That is when DHCP has no authentication by default, basically like our own. So I've never seen this attack before. DHCP starvation or rogue DHCP attack. What just happened? So a rogue DHCP server on a network could hand out fake default gateway. Oh, okay. Okay, rogue DHCP server. Okay, yeah. So this kind of attack happens when there is no authentication by default. So actually when there's no, what am I saying? So regularly DHCP does not have authentication. So if anybody on the network can just get um an IP configuration. Now, assuming an attacker was to somehow get into this DHCP and configure it, what they can do is that they will put fake or malicious gateways or malicious gateways that redirect us to a different um site. So assuming the gateway is publicly accessible on the internet and they put a gateway that is malicious, we could be ending up on their server, we could be dumping our data there, we entering our credentials there, or just things on their server. So that is wrong. So rogue DHCP attack or DHCP starvation. The defense is DHCP snooping on managed switches. Okay, you can just research on that. So I think what your assignment would be to use Wireshark. Okay, DNS, we did this in class. Okay, dig with all these you're querying MX. So I think your assignment will be research these records, study it, these records. This one I didn't really talk about them. You'll be presenting to me in the next class, and the other next one is to capture a DHCP request from your network. So you could use like your Windows on your settings. I think there's DHCP there. So when it's making the response, you capture it with Wireshark. So then you take a screenshot of it and you send it. So this will be those are your two assignments. This and these two labs. So by next class, I think we'll have a test. Yeah. No. So I think that's where we're going to end for today. I think I've given you guys enough assignments. So just do it and communicate back to me. Okay, thank you.